You're listening to China Manufacturing Decoded from the Sofeast Group. Hello again, it's episode 242 of the podcast. Adrian here with Renaud today, and we are talking in early November, this time 2024, about some tips and advice on how to select the right testing lab, or maybe third-party testing lab, as you might call it, for your product testing. Hello, Renaud.
Hey, Adrian, how are you?
Yeah, I'm good. We've all been in China. I've been spending a lot of time in the office and at Gillian, and it's been amazing to get around to Gillian and to see the difference that there is. Every time I go, it seems like there's new equipment or a new department that's been added. And of course, one of the facilities next door is RSQ Labs, which is our in-house testing lab, I think you'd call it. And so in providing some of this advice and in our discussion today, I guess you'll be drawing on exactly what we're doing there in the lab ourselves as well.
I think first we need to start from a macro level of what kinds of testing labs are out there, right? And first, the advice we provide usually is about, let's say, general consumer goods and some, industrial commercial products, etc. But we don't really look into like very specialized, like pharmaceutical labs, some very specialized biological like life sciences types of labs. Some of them go really, really deep in certain topics. Okay. What I'm going to say is just about the most common types of testing labs. Okay. And it's not for like, I want someone to check, I did a health check and they drew some blood and I want to know if I have enough iron or something like that. No, that's more like biological labs. That's not what we talk about today. Okay.
Yep.
Second thing is, within these, let's say, general consumer goods types of labs, what kind of labs? There are some big families. And if we simplify, I would say there's three types of labs that companies, in our general space usually might interact with. Okay. There's calibration labs, there's compliance testing labs, and there's reliability testing labs. Okay. And there might be overlap. Of course, some do, two of them or three of these things, but they usually tend to specialize more in one of them. Okay. So calibration labs, well, when we use even very simple things like a caliper, a micrometer, something like that, we need to calibrate it from time to time. Okay. And either we do it internally. So in that case, for these types of measurement instruments, we have some standards, right? Basically, like pieces of steel that have themselves been calibrated at a high level of precision by a calibration lab, okay, accredited calibration lab. And for some other equipment, we need actually to send it to a lab or to have technician from the lab come to our place to calibrate. Okay. And it can be many things. It can be, for plastic injection press, well, you have some temperature gauges, for example, right? Well, the temperature gauge, you might actually have maybe an infrared temperature measurement device, or maybe something that you put physically in contact exactly at the right place, that, and then your own instruments have been calibrated by a calibration lab, okay? Or you call a technician from a lab to check it, right? But that's a very critical gauge, for that type of equipment. So it's very important to make sure it's accurate. Same thing with timing, actually, right? The injection molding equipment will count how many seconds or something, for the cycle time, how long to keep the mold closed, for example. Okay, that also has to be calibrated. So again, do you use a what do you call that? Like you could use your phone, right? And then that's what some people do for a quick check is you use a stopwatch, and then you check if it's very close or not. But that's not really, you know, the stopwatch within your iPhone is not exactly calibrated. How to make sure it's really accurate? Can we trust it, right? In theory, no. Again, it should trace back to something that has been calibrated by a calibration testing lab if you take quality seriously. Okay? It's just amazing how often people say, "Oh, it's okay, like it's a measurement device. Of course it's correct." And then in the end, well, not really. When you double check, it's like, wow, like it's 5% off. Whoa, I had no idea, or sometimes much more than 5%. So, all that is traced back usually to a national standard, and then the calibration labs within that country will refer to that national standard, and so on and so forth. Okay, so that's calibration labs. Important. At some point, you have to deal with them if you take quality seriously. All right. And by the way, when you purchase a piece of equipment that needs to measure something that is critical to quality, always ask the supplier of that equipment for their own calibration certificate. Okay. And always double check that the precision, like for example, plus or minus 0.1 gram, let's say, is what you need based on the tolerance, on what you're checking or making, right? So it's not a very complicated topic, but people do it wrong like all the time. It's just amazing. Okay, so that's calibration testing. Okay, then one that people deal with a lot is compliance testing. Okay. And that might be certifications. People kind of throw that word certification around a lot, which I don't like. Okay. Testing is usually necessary for certification, but a lot of the compliance requirements do not call for a certification. Test results are usually okay most of the time. Okay. Now, if you go into medical devices, automotive, etc., certain things where you really need a certification, or you have an intentional radiator sort of electronic product you want to sell to USA, for example. Yeah, you need certification by the FCC, etc. But in a lot of cases, most cases actually, there is a route for self-declaration based on testing results. Okay. So here, let's still talk about testing, not certification. So compliance testing, the kind of words that come to mind is, for example, I'm going to sell to Europe. It's an electronic product, for example. So under the CE marking scheme, I need to make sure, ROS, maybe LVD, EMC, and RAD. And then also outside of the CE marking scheme, maybe REACH, POP, and then for USA, whatever, maybe Prop 65 and ROS for certain states, and maybe FCC, maybe UL for electrical safety if it plugs into the mains, and so on and so forth. It might be mandatory, it might be voluntary. Okay, sometimes it's voluntary, but very highly recommended. It's like getting the UL mark, which is a kind of certification. Yeah, getting the UL mark on an electrical product that plugs into the mains, if it's not for a workplace, it's not mandatory. But people will say, oh, then whatever, I don't do it. Wow, okay. Have you done a bit of risk analysis here? What might happen? Was it really designed for that? How are you sure that it's safe for the people using it, right? So sometimes I don't like the idea of mandatory versus voluntary. It should all be based on a risk analysis. Okay, so in some cases, okay, maybe we should get back to that later, but here, yeah, big question is, should you actually test it in a lab? Should you test it in a outside lab? Should you test it in a specially accredited lab? Okay, that's a big topic. Maybe we'll get to that later. So this is where most of the big brands of testing labs, tend to focus on the Bureau Veritas, SGS, Intertek, TUV, the various TUVs, right?
Yeah.
UL themselves, etc., etc. They have Eurofins and so on. There's a lot of big companies there, okay, that focus on that. And there is a myriad, hundreds and hundreds and hundreds of less well-known companies, a lot of them in China, by the way. There's a lot of Chinese testing labs, some of them serious, some of them basically you buy the paper on which the test results
Right.
are printed, but they don't really do much. There's everything, but some of them are very good. Okay. There's hundreds and hundreds, probably thousands and thousands of smaller testing labs. Okay, it's like we discover new ones every week, basically, when suppliers send their test results. Okay, so that's compliance. Basically, they test against typically regulatory and legal requirements from the countries that will import, where the products will be imported, usually.
Yep.
That's most of the time. Okay. And then the third big family is reliability testing. And the main topic here is, hey, we're designing a product and we're not really sure if it's going to do its job. Okay, so that means, is it likely to fail too early in the field, in the hands of users, etc., etc.? Like, could it fail? And then also, of course, could it fail in a catastrophic manner, right? So a lot of people say, oh, like testing for safety, but safety is a very big topic. A lot of the compliance requirements are about safety, not all of them, right? There's more and more compliance requirements about sustainability, for example, right? Also, reliability is directly related to safety in many cases. I mean, the reliability of the brakes in a car, that's directly correlated with safety, right? And in these cases, the compliance requirements actually will call for some reliability testing, right? So that's why there's some overlap.
Yeah.
For example, I don't know, you test. Recently, we had a case where we helped a client. They were working on a stove, and then there's some technical standards from the International Electrotechnical Commission, the IEC, which prepared a lot of technical standards for electrical products. Very, very common, but it's like thousands of of technical standards. It's amazing what they've done. And the one that applies to that kind of stove had a lot of requirements that are actually reliability/durability requirements. For example, you drop something of a certain weight from a certain height onto the stove, and the stove surface should not break, right? Because if it breaks, then there might be access to very, very hot parts, or maybe even to live wires that carry, high voltage and so on. So it's related to safety, and they test it through reliability testing. Okay, so again, there's a lot of overlap. But if we go back to reliability testing, and I think we discussed this several times in the past on this podcast, is that you develop a new product, you don't want it to fail too early. You want to, you could do some testing maybe earlier in the development cycle to find the weaknesses of the design, so you understand, okay, that's going to fail first. Like, okay, the gears are going to fail first in expected usage, or, okay, if we apply this kind of expected stress, maybe, I don't know, a drop test from a coffee table, and it drops from that angle, that is likely to break. Okay, that's very useful for the designers because they might say, okay, then I'm going to make it a bit sturdier or a bit more resistant to whatever the expected stresses. I'm going to change to this other component, or I'm going to add maybe some fail-safe or some redundancy or something. This is a big topic. Reliability engineering is a big topic. Or later in the development cycle, you might test the product to validate that it is likely to keep functioning properly in the expected usage, in the expected usage conditions, with the number of, let's say, cycles of usage and so on and so forth. So basically you replicate the expected life of the product, right? So quite different from calibration testing, that's for sure, and quite a different focus from compliance. A big difference is that you go to a calibration lab and you say, hey, I have I don't know, infrared thermometer, and I need it to be accurate to within 0.2 degrees Celsius. They'll say, okay, no problem. Like, send it to us. Oh, we'll do it. The plan is kind of obvious from the requirements. They don't need to discuss, oh, you want us to do it this way or that way or whatever. It's like very, very straightforward.
Mm.
For compliance testing, it depends, but in most cases, there's not much discussion. Hey, I have these, I don't know, this pair of earbuds, and I'm going to send them, and then the lab's going to look at it and say, okay, well, you send us the bill of materials, so based on this, okay, we see, oh, there might be some phthalates and this and this and that. Okay, so we're going to do this kind of test and the reach and POP, and then for the internals, okay, we're going to do some ROS testing on this. Okay, and then based on the electronic design and the main components, etc. Okay, going to do some test based on such and such standards. Okay, usually it's relatively direct, and the labs usually don't want to go into a lot of discussion about, oh, is this really a must? Or could we do like this? Maybe it's smarter or whatever. They don't really want to do that. So they very often they will actually take some hypothesis without even telling you, right? They might think, oh, well, like this is a cheap product. We're just going to test everything together, for example, let's say for chemical testing. And of course, it's cheaper, but then if it's failed, you don't know which model or which article in the product is non-compliant, right? And then you need more testing. But for them, it's like, okay, they're much more likely to accept the quotation if it's all bundled together. And this is kind of a cheap product. So anyway, that's the only way they would accept anyway. So they would not even ask you most of the time. They would just do it and expect you to say, yeah, okay, all right. How much is it? Okay, send me an invoice. I pay it and I send you the samples, right? They don't really want to go into all that, but there is a degree of interpretation, and that means you ask 3 different labs, you send them exactly the same information. Oh, it's going to be sold in the EU and UK and USA and Canada, and here's the design files and the BOM and blah, 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 blah. Okay, and the user manual and so on. And they might give you 3 different testing plans, and sometimes one is 2 or 3 times more expensive than the other. I mean, it can be quite frustrating. But a lot of the tests that they suggest will be the same. Okay. So still, I would say there's not so much dialogue in general for that. You send it to them, they say, oh, you need this, and it's like, okay, I trust this lab, we'll just go with that. Okay. Now, reliability testing is different. You can't just say, okay, here's the design file, here's the product, what would you suggest? That is not going to lead to a good test plan. Actually, we always charge for developing a test plan. Now, people will say, what? Like, you should be able to give me a quotation for testing right away. But then it's like, no, because that doesn't make any sense. There's no such thing as a standard, except sometimes maybe for testing the packaging. Okay, reliability testing on packaging typically is compression testing, vibration testing, drop testing, right? There's some, for example, ISTA developed certain standards that are widely used, and then let's say FedEx or Amazon or and different retailers have their own standards because they tried to be smart. They looked at the expected stresses in their supply chain to bring the packaged products all the way to the, let's say, the stores, or sent to the e-commerce, maybe to the final customers. And then they came up with something, and they say, well, this is a much better fit than the ISTA standards. Okay. But there are some standards that are already there. But to test a product, especially if it's like a unique kind of product, that doesn't make any sense. It doesn't exist. It doesn't exist. We need to think, okay, let me see what is, oh, there's some buttons here. So we need to think of, button presses, and then there's a USB port. So maybe inserting and removing, a USB cable into it a number of times, and then it's going to do this, going to do that. Okay, is it likely to be dropped? How high? And should it be waterproof? What else? Might be some corrosion. Is it close to the sea? Typically, there's all kinds of questions that need to be asked.
Also, does your requirement for reliability as the producer of the products also come into account here? Because that's kind of arbitrary depending on for the testing lab, depending on each particular customer. Because if you need your product to last for longer, the next customer, they might not need it to last for as long. So that's going to have an impact.
Exactly. Yes. That's where I was going, actually. Yes. We usually ask, what is your reliability target? And some people try to position their product as a higher end product that's going to last longer, etc., etc. And then should be subjected to a more stringent type of test plan. And the tests should simulate a longer usage versus, this is just a giveaway product. As long as it lasts for a few weeks, everybody's happy. No, that's really very, very different, right?
Yep.
And it's going to be used typically on a boat versus, no, this typically people will just use it in their homes. That is extremely different, right?
Yep.
Or it's going to be in a car. Okay, vibrations, There's all kinds of things like this. We need to understand really what is the expected usage and the environment, and what is the reliability target to keep it short, right? So very, very different. The testing is usually done to a customized test plan. That is the key here. So that's the big, try to keep it relatively simple, but calibration testing labs, compliance testing labs, reliability testing labs. These are the big families of testing labs that we tend to work with.
Yeah, makes sense. And the first two are kind of more, I don't know if binary is exactly the right word to use for it, but with compliance, for example, the journey is to get to compliance. That's the goal. That's not going to change. You either comply or you don't comply.
Yeah, right.
But with reliability, it could be anything, depending on, if you're making party hats out of cardboard, maybe the level of testing for that is going to be vastly different to, I don't know, a sensitive radio that's going to be used on a boat or something. So yeah, of course, enormously different there.
And also, calibration labs don't just test, they also calibrate. So certain things can only be like verified. So they just like measure or test and then tell you, yeah, it's still okay, this is what we found. Or they say, well, nah, like no good. Like, okay, and then we have to buy a new one, right? Think of just a ruler, like whatever, a nice metal ruler or something, but it's a bit damaged on the end because it fell down a few times and whatever, and then it bent a bit. Okay, like you got to dispose of it and buy a new one, right? So that's just measuring / testing. But if it's a caliper, thermometer, a lot of things can be recalibrated right there, right? So they don't just test. Calibration labs don't just test. They also provide value, I would say. Whereas the others really just test and give the results, and then it's up to you to decide what you do.
Yes, absolutely. So those are the three kinds of common testing labs that you're like to be encountering. And
Mm.
so next, shall we have a look at the sort of certifications and accreditations they could or should have?
Sure. So it's a very important topic for compliance labs,
Mm,
definitely. For calibration labs, yes, it is important. I would not say it's absolutely a must, but they all get accredited. I don't remember seeing a calibration lab that was not accredited. And both of these types of labs, calibration and compliance, have the common standard. It's the ISO 17025 standard, which is sort of the basic requirements for their management systems.
mm,
Okay. And you can think of it as ISO 9001 plus some requirements specifically for testing labs. And these specific requirements are not like ISO 9001, which is very like general and like you need to have a system, but you don't need to do a good job. Like you just need to have a system and stick to it, right? This is and try to improve it over time. This is ISO 9001. The specific requirements for the labs in ISO 17025 also require that they establish their competence. Okay, so they need actually to cross-check their findings with some other labs' findings, typically, or in other ways. But anyway, to keep it simple, they need to sort of prove that they are competent and that their findings actually are correct. Okay. So that's for calibration labs and compliance labs.
mm,
Now, reliability labs, that's different. There are some ISO standards that might apply, but how to say, reliability labs, a lot of them are not accredited and they don't care and their customers don't care.
mm,
It's more about, you know, do you have the right equipment? Do you just run the tests, in the proper way, and that's it. So they of course they can be accredited or they could be like certified to ISO 9001. I mean, of course that doesn't hurt. That's a good thing. But nobody really pays attention to accreditations here, right? Because a lot of the value that they provide actually is in the consulting, around the testing. The testing itself is kind of commoditized, it's simple, it's okay. You can find 100 labs that would do it. And again, nobody cares about the accreditations. However, how do they set the custom test plan, as I was mentioning before? This is sort of consulting. And also, how do they help you interpret the findings? And in case of failures that you really want to investigate, can they actually look into the design of the product and so on? And look also, of course, at the failed samples, what actually went wrong, why, is it, I don't know, metal fatigue? Is it because the component is underrated? Is it right? Or the gears are made of, I don't know, a plastic that is too soft,
mm,
whatever. It could be a lot of things, but it's really again back to, let's say, consulting with a product design focus and very deep understanding about the product itself to get to some actionable advice.
mm,
Okay, so the focus is much more around that, around the understanding of the design and the expected use of the product and how to translate that into test cases, etc., etc., etc. Okay,
mm,
and ISO 17025 clearly, just says it's for calibration and compliance labs, right? They really don't look at compliance labs as a separate entity. All right. Now, again, there's some overlap in compliance labs. have to do a lot of compliance testing because it's part of the technical standards very often. So
Yeah.
for that, they need to prove again their competence, etc., for these tests. But there's also a lot of other tests that are typical reliability tests that they would never do. Okay, so there's some overlap, but it's far from a complete overlap.
Mm.
Does that make sense?
So, you as the customer, then with the reliability testing lab, you need to make your own assessment whether they've got the competencies to be able to help you with your product then. So you're going to have a lot of dialogue with
Yeah.
them and and really make that decision based on what they're saying.
Yeah, basically you need to think of them, maybe it's two-thirds consulting and one-third testing,
Right.
right? It's really quite
Mm.
different, right? But now to get back to your question, ISO 17025 is one kind of accreditation. Okay, it's sort of the basic accreditation, typically for compliance, testing labs
Mhm.
and calibration also. Okay, fine. However, this is sort of the basics. You often need to go further, right? And you really need, let's focus on compliance for a moment, because I think a lot of our audience are concerned about, what exactly for compliance, what exactly are the requirements, what to look for, and so on and so forth. You need
Sure.
to start from the requirements themselves. And the labs will not really tell you about that. So for example, you want to test for ROS. Okay, ROS is a directive in the EU. It does not tell you you must test. Okay, it just tells you there's a restriction on the proportions of, certain substances in each part of your product, each part that can be mechanically separated. Yeah, will be checked like separately. And then if we find that it's, any one of them is above that certain limit, the product is non-compliant. That's the way that the market surveillance authorities would check it. But the ROS directive does not say you must test. Because if you buy, I don't know, let's say you buy glasses for drinking or something like that. Okay, no, sorry, should be electrical or electronic. We're talking about ROS here. But let's say some of the components in your product are made of, let's say, Triton plastic, which is hard, very transparent kind of plastic made by a big chemical company called Eastman. You don't need to test for ROS. You just look at the technical sheet and it comes from a big chemical company, non-Chinese. I mean, if you are sure that it's really that plastic that is used, only that plastic, nothing else mixed with it, that's injection molded and then goes into the parts that go into your product, why would you test it? The
Mm.
risk is near zero, right? So the ROS directive does not tell you you must test. Now, in some other cases, the risk is pretty high, so you really should test, right? At least for the first production and then like once in a while again, right? So that's an example that actually does not tell you you must test.
Mm.
Let's look at another chemical regulation about chemical content, REACH. That's for the EU, for basically all consumer products. And this one tells you you must test for the substances of very high concern. Okay, now it does not tell you you must test for all of them. If you buy a product, let's say it's just plastic, yeah, you're going to test for phthalates, BPA, and so on, whatever, really applies there. But you're
Mhm.
not going to test for things that are only likely to appear in certain metal alloys, for example. Okay, so first you test only for those that are sort of a risk. And it does not tell you you must test in a ISO 17025 accredited lab. No, actually, if you have the right equipment, you can test yourself in your garage, as long as you document it, these are the findings. This is what I tested it for. These are the findings. That's actually fine. Okay.
Mm.
Then let's look at another example. Let's say you sell an electronic product that has, let's say it has a Bluetooth module, and you sell it to the USA,
Mhm.
and your microcontroller, let's say you use a microcontroller and then like a separate module for Bluetooth, and it's not pre-certified, it doesn't come from its own FCC ID. So you have to go for full certification here and get your FCC ID for your device. Now, FCC is very clear in that case. The FCC, that commission in the US is very clear. It says the testing must be done in one of the labs that we recognize. Here is the list, all right? And the list includes a bunch of Chinese labs. I mean, it doesn't mean that it's like a small club and the price is very high. There's very intense competition between the labs, but you must pick a lab that is in the list. Okay. Another example would be also for the US. Again, for electrical safety, a product plugs into the mains and is going to be used, let's say, in factories. So it's for the workplace.
Mm.
Definitely, you need to have the UL mark on it. Now, UL mark does not mean it must be tested and certified by UL, the company. No, absolutely not. Now, it might have to be tested and certified against a technical standard published by UL, but it doesn't mean that UL as a testing organization need to be involved. There's the OSHA, which is the organization in the US that is in charge of workplace safety, has a list. They have a scheme, the National National Recognized Testing Laboratories. That's a list, and there's a bunch of labs. All the very big companies that you would think of are on the list, but there's also some smaller organizations, but they are all in the USA and Canada, for example. Can't be done with the Chinese lab, right?
Mm.
So, so in this case, it's a little bit more like a club. Okay. And same thing, if you go with, let's say, some relatively safety sensitive kind of personal protective equipment or relatively high risk medical devices in the European Union or a bunch of other types of products, right? There's some others. You need to work with one of the notified bodies, right? So you need to go to a database called NANDO on the European Union the Commission website, and it will tell you, okay, for that kind of product, right, whatever, a class 2 medical device, okay, this is the list, right? For non-in vitro medical device, class 2, here's the list. That's a club. Okay, you need to work with one of these in the club, and they will work with you on certifying the product. Okay. So, and of course, these guys that are in the club, they are sorry, I should say ISO/IEC 17025. It's not ISO 17025. Need to be accurate. But anyway, they are not, of course, they are accredited to that ISO/IEC standard, but it's just a starting point. They need to pass some extra hurdles, okay, to be on the list in the club.
Yeah, absolutely. And I think you have to tailor, you got to tailor what you're going for based on your requirements. I think understanding exactly what's needed. So for compliance, we know what we're looking for. Maybe for reliability, it's more down to your personal requirements. In China specifically, should we look for a specific Chinese accreditation for labs? Because, as you said, a lot of labs in China.
Nope, not as a general rule.
Okay.
If they're accredited to ISO/IEC 17025,
Mhm.
it will be the accreditation by the CNAS. Okay, I don't even know if they have an alternative. I don't think so. No, it's always by the CNAS, which is the National Accreditation Body. So again, you start from what compliance requirements apply, do your risk analysis together with that, and then from there you see what exactly does it say. what exactly does it recommend, or what exactly does it require? Sometimes it's a bit vague. Like
Mm.
US FCC, if it's non-intentional radiator, for example, you don't need to go for certification, but they tell you you must test. Okay, so where? And then they just say, well, a competent lab. Okay, what does that mean? Now, of course, it's pretty close to saying the lab must be accredited to ISO/IEC 17025 with the scope of this specific technical standard for the US, etc.
Yeah.
Okay, but it doesn't exactly say that. So what it says is don't do it in your garage. Do it with
Mm.
a lab that is used to doing that.
Mm.
And yeah, 95% of the time, yeah, it really should mean accredited to that ISO/IEC standard,
Okay.
right? So start from the requirement and understand the requirements. And if you're not really sure, yeah, try to get information from people who know. Don't just Google and go on some blogs from some consultants, maybe might have been written a few years ago, by the way, might not even be relevant today.
Mm.
And there's a lot of very inaccurate information, out there on the web. So be careful and do not use ChatGPT for that. I
Mm.
repeat, do not use ChatGPT or Claude or whatever, Llama or whatever. Just stay away from this stuff. Okay. Go to the source as much as possible.
That's yeah, tempting as it is these days to use Chat GPT for stuff, but yeah, it's experts are required. I have a quick question, right? Earlier on, you mentioned that we ourselves, we get in components and things like that from different suppliers in China, and we encounter new testing labs because they've had testing done at different labs. Now, if you're receiving something from a supplier and they're giving you proof that it's been tested so that you have a test results, in general, I think I can guess what you're going to say here, but in general, should you trust this?
Well, again, risk analysis and go back to the requirements. Is it actually what is required? Very often the suppliers send you something and say, oh, this is what it is. And you say, well, I asked for MSDS and you send me a ROS testing report. Like, I don't care about that. I want the MSDS, right?
Mm.
Okay. You need to know actually what you're looking for. Oh, I want the battery specification sheet. Well, what do you mean battery specification sheet? Okay, let me go on whatever Panasonic website, get one of their battery specification sheets, send it to the supplier. That's what I want. They're like, oh, whoa, we don't have something like that. Okay, wrong supplier.
Yeah.
Next one, right? You need to source to compliance. So first thing is you need to actually know what you're looking at and what you need. Then if you say, okay, I want to make sure this is whatever, REACH compliant, they send you something, you look at it, it's the right kind of report. Okay. Is it from a known testing lab or a testing lab you never heard of? Is it like 5 years ago? Is it on that exact same product? There's all kinds of questions you need to look at. Is it in JPEG? Why is it not in PDF? What kind of a joke is that? Like no lab issues a JPEG or something. It looks like it'd been Photoshop maybe. If it's important, try to contact the lab. Have your people on the ground, contact the lab. Sometimes they have a link. They have like a database that you can search and just confirm, yeah, this really actually happened. This test number really happened. It tells you a little bit of information. It's not completely fake. Okay. But there's so many unknowns here. Like maybe it's the same product, but was it exactly the same material? No idea. Basically you need to take everything with a grain of salt and sort of question everything. Okay. And if that's really important, well, you need to drive the process yourself, basically. You need to drive the process yourself. And in the end, even if you push a supplier to pay, well, in the end, you will pay through the price you pay, right? So be mindful of that. But
Good.
usually serious companies that, how to say, that take compliance seriously, and especially if they don't deal with a lot of different products, usually they end up paying the testing themselves. Now,
Mm.
big retailers and so on, that's different. They play a different game. Can't really, we should not compare. It's a different world, right? But relatively small importers and brands, that's what they should be looking at.
Good. That's a good way to round off this particular episode, because I think it sort of empowers everybody listening to go forth and start to select the right lab and ask some of the right questions, which I think is the key here. So yeah, we've reached the end, but there is one more thing that I just want to mention, Renaud. Different topic. Soon, on November the 14th, you're going to be one of the guest speakers of a webinar that's coming up with the crowdfunding TCF team. So it's the crowdfunding formula team. And
Right.
it's basically a webinar to enable you to have crowdfunding and product launch success. The title is Maximizing Manufacturing Efficiency and Backer Management for Crowdfunding Projects. That's a bit of a mouthful, that is, but I've said it now. So I'm attending. I'm sure that some of our listeners would definitely be interested in that if they are thinking of launching a product soon and going down the crowdfunding route. You're going to be speaking kind of about the quality side of things, right?
The more like the product development and going into manufacturing part of it. Of course, quality is a part of this. Like everything impacts quality, right?
Yeah.
But it's really about not skipping the right types of validations and doing things in a smart but structured manner. So you don't need to go back into the previous phase and so on. And some ways to go into mass production, sort of, let's say, intermediate mass production, first orders, in some cases, before actually making the tooling for mass production. In some cases, that kind of makes sense. And, that's for the crowdfunding sort of crowd, if I might say that. They're always in a hurry. They're always late. So this is the kind of things that's important on their minds usually.
And there are two other speakers as well, at least. So they're going to be also covering topics around crowdfunding. So I think that promises to be a good one. It's completely free. So I will leave the link in the show notes to the episode, and it's going to be done over Zoom, I believe, right? So you can go sign up for that. And that is on the 14th of November, 8 a.m. Eastern time. Given that it's on Zoom, I assume when you sign up, you'll be able to watch it back as well if you can't quite make the exact time. But yeah, that's going to be a good one. So November the 14th, you'll be speaking. So we will see you there. Let's wrap it up for this particular episode. Good one, discussing about some of the decisions you need to make and some of the questions you should be asking when you're looking for a testing lab. And as ever, we will be back next week.
All right. Thank you.
Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.